All right. Before I forget, thank you all for coming. I really do appreciate it. It's really nice when we can talk about what we do and educate people on how to do their jobs. And often we find out things from you that educate us because we don't know everything. We know some things. And we need to take what we know and apply it to what you guys do. So for that, I thank you and for being here. I guess what I would like to do is maybe start off talking a little bit more about the gear, and I want anyone to ask any question that comes to mind, and we'll answer that. And also our panel will also, talk about their experiences as well. So something I put out almost a year ago, I think, was sort of a thing where I talked about how to get great range out of your wireless. And wireless range is a function of many, many things. I mean, there are people who will go out and say, I can't get 10 feet out of my wireless, whether it be Zaxcom or whether it be other brands. And then there's other people that say, I get 500 feet out of it, and this is great. And I would say the biggest things that influence range are interference and antennas and intermodulation. Now, intermodulation, while being a large, unwieldy word, is not difficult to deal with. And in fact, when it comes to digital wireless, a long time ago, we basically eliminated this intermodulation problem. Intermodulation is a function of two things. It's a function of receivers and their ability to not overload when receiving signals, because if they overload, which effectively is like audio clipping but on the RF level, they tend to mix things together. So with intermodulation, if you have two transmitters a megahertz apart, well, if they get really physically close together, like if two packs were like almost touching, they would tend to mix together within the packs and generate the harmonics that would be spaced every 1 megahertz. Digital wireless doesn't tend to suffer from this problem. Analog wireless, has that problem, and has always had that problem. There's things that the manufacturers do to mitigate that, but with our digital wireless, everything is very linear, so nothing really overloads. So you can equally space your packs, okay? If you have the ability to not do that, in other words, if you have enough frequencies available that you can follow some sort of intermodulation plan, and there are many programs that do this, that'll tell you what frequencies you can use, it's always a good idea to follow that kind of plan. But with Zaxcom, it really isn't a necessity, especially if, again, the packs aren't necessarily touching. But when it comes to using things, I mean, there's a lot of things that I talk about that are very beneficial. In other words, when it comes to the intermodulation part, you end up getting that because something is overloading. So overloading meaning a transmitter might be just very, very physically close in distance to a receiver. Probably one of the worst things that can happen to you as a sound mixer, and you guys can let me know if this has happened to you. I think it's happened to almost everybody, where you've got some actor who's not in the scene, and they'll come over to your sound cart and stand behind you with their transmitter on, right near the antennas on the cart, and basically overload the receivers on the cart. We call that a near-far problem, because that overloading can cause, again, this kind of intermodulation and interference in your receivers. So it's always good to make sure that you don't have any transmitters that are in your sound bag or near the cart when you're working. If you've got 10 transmitters that are on and they're all 20, 30, 40 feet away from you, that's great. That's what you want. But if you have 10 transmitters that are on and then someone is literally 2 feet away from you in the cart, that's really bad.
And you should say away from your antennas.
Thank you.
Yes. Some of us, I know, Cujo, and some of us, and And Marcus, we remote the antennas.
Exactly.
So generally the antennas are not near me majority of the time.
Exactly. Now, when it comes to antennas, here's a double bonus for everyone. If you take your antennas and you put them as high as possible over the cart, I mean, I don't know what distance you guys do, but I recommend if you can get 10 feet out of it, you should get at least 10 feet out of it. And Cujo will tell you yes, or may he tell you more. But
10 feet is my minimum, although I recommend everybody try to get to at least 12 to 14 feet.
I would totally agree.
Biggest C-stand I can get that I have built onto my rack.
Yeah.
Get my antennas up and over everything.
Right. Now, the reason to do this is multiple, basically. By getting it so high, if someone does come behind you on your sound cart, well, you know, with the antennas 14 feet in the air, it's 14 feet away from the closest thing, which means that the ratio of a close transmitter to one far away is a lot more favorable than if the antennas are down low, maybe, you know, 6 feet in the air. So getting it up there eliminates that problem. The other best thing you can do, and there might be people that disagree with this, is especially, you know, when you're on a cart, is never, ever use dipole antennas. Use a shark fin, use a directional antenna. The reason for this is really quite simple. A directional antenna can give you 8 or 9 dB of what we call forward gain. So, you know, that signal is going to be, you know, so much stronger coming into the cart in the first place. Just for reference purposes, to go double the distance, okay, you need 9 dB. So literally, a shark fin antenna that has 9 dB of gain is going to double your distance, okay? But the best part is that it actually attenuates signals that are on the sides and behind the antenna. So if you can get that 9 dB forward gain, and let's say you get 9 dB of attenuation, okay, on the other transmitters, I mean, it's going to vary depending upon where it is, but that's a 4 times difference. That means that you will, if you have an interferer, okay, that you're attenuating and you have the signal that you're trying to get, literally you're going to get 4 times the distance, okay, you know, versus having a dipole antenna. And that dipole antenna is vertically polarized, so it's going to give you like a donut-shaped, you know, or round configuration. The great part about what we do is that if there's a scene taking place, you know, 50 feet in front of me, it's in front of me. You're not going to have an actor that's not in that area. They're not going to be behind you. They're all going to be in that scene. So that is certainly the most favorable thing that you're going to have. So always use, you know, on a cart, shark fin antennas. Even in a sound bag, directional antennas, if you can do it, you know, will give you the same advantages overall. Obviously, if you're in a sound bag, you're not going to have that antenna, you know, high up in the air. You know, I mean, you could, but you're going to look really silly.
Generally speaking, if you're in a bag, you're much closer to set and talent. So height then becomes slightly less critical.
Agreed. Absolutely. So, you know, sound bags are much more limiting in terms of, you know, getting this kind of directivity and attenuation, but it's always a great, you know, a great thing when you can be out there with a shark fin. And, you know, basically our wireless when it comes to the range, and I could leave it to these gentlemen to talk about range, but, you know, with shark fins on our wireless, you know, getting 500 feet is not that difficult. When it comes to range, there's something that is, you know, really important. It's placement of transmitters.
Well, speaking of that, I'm going to jump in here and tell you a funny story with Mr. Sanders. It was Marcus and Kevin and I. We were at the mothership in New Jersey and doing some tests on at the time, these were brand new transmitters, and doing some range tests. And Glenn was like, oh, well, yeah, I'll just clip it on the side. I go, oh, no, we're going to put it on their ankle. this is real world. And he got so nervous of us doing the test, because he never does tests when putting it on somebody's ankle. But at least in my world, hey, the ankle is like the #1 spot, or at least for most male characters. And Glenn was kind of concerned. He was even trying to pull the antenna out from the pants and everything. And I said, "No, Glenn, no. This is real world. This is what we do." And we had great results, and it worked out incredibly. And the range was incredible, and everything. But Glenn was doing everything to try to keep that transmitter from being on. It was one of his employees' ankles. But and it worked great.
Can you explain, if you haven't already, why you believe only needing antennas like this far apart, what that's all about?
I'm going to let Cujo answer that one for now.
I'm not
It's
understanding.
generally accepted practice that your antenna should be somewhere between 1/4 and 1/2 wave apart. Spreading them out further in hopes of getting better signal reception is somewhat erroneous, because the chances of a null happening to both antennas from this distance to 3 or 4 feet happening at the same time on both antennas is effectively impossible for anything that we would ever need in our world. So as long as your antennas are somewhere between 1/4 and 1/2 wave apart, you will have the best possible reception for that antenna, or for that antenna pair. The other things that come into play that, in my opinion, are far more important and bear out in testing is antenna placement physically within the space. A lot of us, our sound mixers, we like to hide in the corner, and then our antennas are sitting right here. Putting your antennas against this wall seems like a good idea, but it actually dramatically reduces your range. Your antennas need to be, generally speaking, at least 2 feet away from the wall.
Do you believe that because we're picking up like more bad harmonics that are bouncing off the
Well,
wall?
because most modern construction uses metal studs in the walls, and now you're putting your antennas right up against a big wall full of metal studs that are now going to act as additional antennas. You're going to suck in more garbage than you want. So get your antennas away from the wall, use short cables, really good cables, passive antennas every chance you can. In my opinion, and this also bears out in testing, 99% of the problems that people have with reception is because they're overloading the front end of their receivers by using powered antennas and jacking up the gain to overcome. They think they have weak signals, so they jack up the gain on their antennas, which really just pollutes the noise floor.
Can you translate waves, half wave, quarter wave to measurements because we're dealing with frequencies and...
Every frequency has a wavelength. It depends on the exact frequency as to how long that wave is, just like a sound wave, right? So for proper antenna reception, in a perfect world, the antenna would be the exact same wavelength. The antenna length would be the same length as the wave, right? So you would get the entire wave in your antenna. For what we do, as long as it's an even multiple of 1/4 of a wavelength, which I think, I have to go back and look it up, but in the 400 to 500 megahertz-ish range, 1/4 wavelength is about the size of a pine needle.
It's about 6 inches.
Yeah. So as long as your antennas are 6 inches apart, you're pretty much ideal. So
That's at 470.
that's at
So you get up
470.
to 616.
But now you get up at 616, you're still not that much bigger. Your
Well, it's smaller.
antenna length is going to be a lot shorter because of the higher frequency.
That's right.
So you can get away with a much narrower spacing. But the reality is for the work that we do in our world, the wavelengths that we're dealing with are between roughly 3 to maybe 7 inches at the extreme ends. So as long as your antennas are a quarter or a half of that distance apart, you will be in ideal
Yeah.
situation. Okay.
So in practical application, we get in situations where we have concrete walls, windows, door openings, and various other hard, metallic, whatever,
Sure.
objects. At times, I'll point in a couple of different directions.
And that's okay. That's perfectly okay. That's
Sometimes I'll
actually
go
Well-
high-low.
the perfect orientation. A lot of people run their shark fins straight up and down, which I also do.
Yeah.
Laying it over like this.
Yeah.
Instead of having your shark fins be vertical and pointing directly, you can lay your shark fins over at about 45 degrees and still have them facing your talent.
Yeah.
And you will not always get an improvement, but scientifically speaking, if you were to measure that out, that
Yeah.
is the most perfectly ideal setup.
Yeah, it's really about averaging, so to speak. I mean, the thing about a pack is, if its pack is on someone, it's good for it to be vertical, but it's probably never vertical. It's going to be like this or like that or whatever it's going to be. And then the signal bounces off surfaces in an infinite way. So, just like Cujo said, if you do this, what are you doing? You're sort of splitting the difference as far as polarization, and also you're averaging out. So, I'm not in total agreement with that because, there's an infinite number of signals that you're receiving, and they all add together at the antenna. But certainly doing that can be an advantage. It depends on the situation. Basically, just to confirm what Cujo said, as long as you are a quarter to a half wavelength apart, it's fine. I mean, is it an exact science? No. Is it wrong to be 2 feet apart? No. Does it really matter past a certain point? Really, no. So, I think, for me, I let people go about 1 foot apart because it's certainly more than a quarter wavelength, and frequency-wise, it really doesn't matter because the wavelength changes whether you're at 500 megahertz or 600 megahertz. There's a little difference, so you're definitely beyond where it matters.
And to further clarify part of what you said about having them pointing in different directions, if I were in a large room, I would have antennas spaced very far apart because I want the coverage pattern that each antenna gives. If I have both antennas a foot apart pointing here, then I'm potentially missing the corners of the room.
But isn't there a danger in doing that? Isn't the danger in the whole idea that in the unlikely event that a null happens here, it'll be captured here because of multipath? And if you put one way over there and one way over here, aren't you essentially isolating this and negating that benefit?
To a certain extent, yes, but if the room is sufficiently large that 2 antennas are going to leave me a big hole in the middle, I'm going to drop another antenna.
Yeah, I think that, that's fine in the applications
That's
where you
more
have.
rare than it is common.
Right, when you're talking about, let's say being outside and you've got people, again, all in the same direction, then it would be my advice to, point it in that direction because you know where they are. They're not going to be off on the sides, and there's really nothing to reflect. So you want to get as much gain as you can get going in that direction. If I can get back to the powered antenna thing, because Cujo and I are exactly on the same page. And I've said this in the paper that I wrote. Powered antennas are, except for one situation, are basically snake oil. They can do a lot more damage than good. The only reason, in my opinion, to use a powered antenna is basically if you have a tremendous amount of coax loss because you're using cheap coax over a very, very long run, and that amplified antenna can take a weak signal and push it up high enough that the receiver can actually see it and do something with it. But if you're using coax that's that long and that lossy where you need a powered antenna, you're not using the right coax. You should buy much better coax, and we recommend if you can deal with the fact it's thicker, something called LMR 400. You like that? Yeah.
Use the 240. You just LMR 400 snake that my utilities hate.
That's really, really good. You know, the thing about running coax is there's this thing where, you know, the world, okay, the free space has noise, okay? So let's say the noise of free space is 5 dB, which means you have to overcome that by a certain number of dB to have a signal. So if you have 5 dB loss in your coax, well, that cancels out the noise in the world. So you can have some loss in your coax, and it's not going to affect you at all. Maybe if you're in a cornfield in Iowa, but none of us really work there. So in any case, the powered antenna thing, you know, definitely stay away from that. Spend your money on better coax. And I would say the second best is LMR 250.
240.
240? Okay, 240. I stand corrected.
UF, Ultraflex.
Okay, yeah. And that's going to be much more manageable, still pretty decent in terms of loss. If you can remote your receivers and use short coax runs, that's better, because there's no loss by running audio cable or Dante, you know, but there is loss in coax. So, you know, very much so, you know, buy the better coax and, you know, keep them relatively short. They're going to be, you know, the receivers on your cart, you know, you don't need a long run to go up 14 feet. It's not a big deal.
I have 25 feet of cable on my rack.
Perfect.
That's all I ever need.
And I know the 240 at 100 feet is 8 dB loss.
Yeah, so you're at plus 1 dB. If you're using passive shark fins, you're still at plus 1 dB when you hit the front end filter, which is just about perfect.
And I think it's actually spec'd out at 9 dB loss
Yeah.
per 100 feet, but I've read the cables and they're one's 7.9, one's 8, the other's 8.1 maybe.
Yeah, let me talk about passive filters, okay? All of our receivers have what we call strip line filters. We don't use SAW filters. We don't use them for a major reason. They're not that good. I mean, they only give you about 30 dB, 40 dB of attenuation. They're fixed. Our filters are tunable, so we can have this window that we can put anywhere we want. The problem is out there, and you know, I think it's important for everyone to understand, if you have a transmitter that's on UHF, let's say, like right now, our transmitter that transmits to our URXs is on 512 megahertz, so it's at the bottom. So I've got one of our filters in line with that, and that's cutting off the RF so that any spray or, you know, low-level noise is basically cut off at about 20 megahertz away from that signal. And what that does for you, it lowers the noise floor on receivers that are very, very close. In other words, when I say close, distance-wise. In other words, if you have an IFB transmitter in a bag and you have a wireless receiver in a bag, you can't do anything about any quote-unquote spray from a transmitter, which they all have to a certain degree, unless you put a filter on that transmitter. You know, even though we have the same filters in our receiver, if the noise is on channel, so let's say there's a little bit of low-level noise, raising the noise floor of that receiver by 10 dB or even 9 dB, that's going to cut your range in half on the receivers that are in the bag. By putting the filter on the transmitter and lowering the noise floor where you're trying to receive, then there'll be no interaction between those. And you know, you must have a filter on the transmitter if the antennas are that close together. There's no receiver that eliminates the need for that transmitter filter. It's just a physical impossibility to put a filter on the receiver and have it eliminate that noise that falls within that filter band. So, you know, it's just one of those things. So it's really important that if you switch on your IFB transmitter, whether it's in a bag or a cart, and you see the noise floor come up on the receivers, then you have an issue. You need a filter. You need to move your frequencies further apart, possibly, to fix that. So it's really it's really an important thing.
Obviously, there's a lot of technical that was given by Glenn, but we all have to consider environmental factors and just common practices in terms of extending your range. Being in the middle of a cornfield, if you have your transmitter on the back of an actor who's facing you, you're going to have a hell of a hard time picking up that transmitter. Transmitter placement is everything, and putting it down to the ankle is not only what we normally do just to keep the transmitters from showing on camera, but in my opinion, it's the best placement because you usually always have better direct line of sight to something that's on an ankle, no matter which way an actor decides to turn. So transmitter placement is always key, as well as look at your environment. If you have nowhere for a transmitter to bounce back to you, say you're in the middle of a field. I mean, I've ran into this on Walking Dead for years, sitting in the middle of a field, trying to pick up somebody who's 500 feet out into the middle. And there's a barn over here, and there's nothing over here. You can always count on a reflection to kind of come back to you to pick up that transmitter. So always consider your environment as reasons also of why you might be losing signal loss.
For back in the day on Walking Dead, when you faced that situation, would you choose to point your antennas directly at the action, or would you point them at the barn, or how would you?
I would always try to get direct line. I would always try to get it right from the actors.
Okay.
Yeah, but obviously another thing that maybe Cujo can talk about is that floor plane of the ground does affect signal as well. Even though we do put it there, we do get a nice better direct line of sight. There is an issue with bounce off the ground and whatnot. But many times I would have to lift the transmitter off the ankle and put it on their gut as they're walking towards us, as opposed to putting the transmitter on their back.
If I can kind of add to this a little bit, there's two things going on when it comes to range. There's the UHF transmission from the pack to the cart, but with Zaxcom, there's the Zaxnet transmission back to the pack. So, we want to see, good remote control range. And what we have going on, which differs from what everyone else tends to do that has RF remote control, is Zaxnet it's not a typical Bluetooth or Zigbee or any of those more consumer formats. It's our own thing, very narrow in bandwidth relative to the others, which gives it the ability to penetrate much better for reasons that are a little too scientific to go into at this moment without spending too much time. But the thing about what we do, it's a one-way communication. Okay, when you talk Bluetooth, when you talk the other formats, generally speaking, you'll send the command to the pack and it has to acknowledge that it got it. With us, we don't need acknowledgement. All we do is send it out to the pack receives it, the pack changes gain, the pack jams code. It does all of those things. And a lot of our customers, even though we don't sell it directly, do use 1-watt amplifiers, which they can do. And that gives us remote control range in the range of hundreds of feet, which is really important, especially when you're outside. Because as Michael talked about, if that pack, which doesn't have an outside antenna, the 2.4 gig antenna is in the pack. So if that pack is not facing the transmitter, there's a tremendous amount of attenuation of that signal. So where if it was facing you, you could get, maybe 100, 200 feet easily enough. If you're in the middle, you might be down to 20 feet. So, our Zaxnet gives you that kind of range. And when you talk about the more consumerish things, while a consumer format may spec 100 feet or 200 or even 500 feet of range, the practical consideration on the range of a wireless transmitter with, again, Bluetooth, Zigbee, what have you, can be substantially lower in the range of 10 to 20 feet, which for what we do, I don't think is acceptable. So, the Zaxnet transmission format and the range, I think also really sets us apart from anything going on in the industry.
Your innovations in perfectly serve the growing complexity of shoots. That, I mean, the difficulty, the expectations of range, the stuff that they throw at us.
Oh, yeah. I mean,
So stop, because they're trying to supersede you.
well, the problem is too many people use 2.4 gigs for all kinds of things. So, you know, the amount of interference out there, especially on a TV or film shoot, you know, the noise floor, quote unquote, because you've got all these wideband signals that are using Bluetooth that are maybe 20, 30 megahertz wide. To a system like ours, that's noise. Or to any system, that's noise. And for us to be able to overcome that with a greater signal so that we have range is really important. And, you know, it's the more things you put into 2.4, the worse it is, you know. I mean, ultimately, you know, with us, you know, we don't require Zaxnet to run. I mean, you've got the backed up transmitters with their recordings. It's not like we're doing something like frequency hopping, which requires a more substantial kind of system. You know, where if you can't remote control your transmitters because of interference, then frequency hopping doesn't help you. And in fact, it's generally not a good idea just because you don't know where it's going to hop to. I mean, maybe it says, okay, I think this is clear, but it could hop onto some frequency that's being used on the next soundstage.
Cujo put together a product that I went to production and basically said, I want to bring in an RF coordinator at the beginning of a production just to kind of give us where to start with. I involved the camera department, the lighting department, video assist, and visual effects. And the production office, thank you. Because our stages were at the production office. And basically just to get a roadmap of where to start with frequencies and who was on what and where. And Cujo, I'll let you talk about your recipe there, but he had basically put a box on our stage that sat there and he could remotely scan because it was connected to the internet, but he could scan and see who was doing what and could send me a picture of it. And basically we would help camera and some of the other departments when they started having problems with their follow focus or the lighting department, or we pretty much, I stayed clean the whole time, did I not, Cujo?
Yeah, you were perfectly clean the whole time.
Yeah.
And so in addition to being a production sound mixer, I'm also an RF coordinator and part-time gear junkie. With the compressed RF UHF spectrum that we have to use for our transmitters, that's been a thing, and we've all sort of gotten on board with making sure that we properly coordinate and make sure that our gear is operating in legal bands. And in my opinion, anybody that's not buying wideband digital gear is setting themselves up for long-term failure, but that's a different conversation. So when it comes to the 2.4 and 5 gigahertz spectrum that Wi-Fi uses, Glenn is spot on point with having a very narrow beam frequency send that's just a one-way send, because when I did Blue Beetle with Whit, I came into the stage, I did some baseline scans with my different gear. We got an idea of what the RF spectrum, both in the UHF and the Wi-Fi bands, looked like as a baseline. And then we spoke with lighting, we spoke with camera, we spoke with everybody we could about what gear they were using, what channels that they were using, and what their power levels were. Then I took that information and I have some boxes that I've put together that allow me to remote monitor the RF spectrum from the UHF side and also from the Wi-Fi side, so I can monitor 2.4 and 5 gigahertz. So what we were able to do was we were able to find what channels camera was using, what channels production office was using, what channels lighting console was using, and anybody else, like special effects, you know, the guys that come in with the techno cranes, they always have their own comm system. We were able to isolate all those, and I was able to give them channel assignments that help coordinate their own frequencies. I was able to get the production office to turn off everything that was on 2.4 gigahertz in the production office and leave it on the 5 gigahertz band, because most of the gear on a film set is 2.4, except for the new Teradecks, which are now, I think they're running 8. Some of the newer ones are running 6 or 8 gigahertz now, which is far enough away from everybody. And because of the ability of those devices to be able to be assigned and locked into a channel instead of just channel hopping all day long, we were able to isolate each department and give them their own bandwidth to work in. And I think you called me 2 or 3 times.
Yeah, when camera was having
Camera was having problems with their follow focus.
and then we told them to go lower, which they always went higher, and lower was
Yeah, and I would
solved the issue.
I could open my laptop and pull up the scan and say, okay, they need to go to this channel and stay there, and it would work, but they didn't always listen. But I gave Whit some pre-coordinated frequencies at the beginning of the show, and it worked perfectly for him.
Yeah, it was great till we went on location, but anyway.
So, yeah.
But it worked great on all the stage work, and again, this is something you have to sell your producer or UPM or production supervisor, whoever you're dealing with, of them paying Cujo for. How many days did you charge them for, Cujo? Couple?
3 days total for the whole run of the show.
Yeah, and then there was the rental of your scanner, correct?
Yeah, and the equipment rental on the device.
Which that wasn't that much.
No, that was.
But I don't know, have you been on the set when everything shuts down or when the dimmer board shuts down? And I mean, and everything comes to a grinding halt. There's 100 people standing around for 15 minutes till somebody can figure out how to get their frequencies working again. I've seen it happen a few times. Yeah, and that 10-minute, and if you added up throughout the show, you know, they've lost maybe an hour of production time, which that's, on most productions, is tens, yeah, it can be, but tens and tens of thousands of dollars. So what little cost it is to bring Cujo in for a couple of days and to rent a scanner is nothing compared to, I'm trying to give you a selling point to sell your production.
I actually, I'm consulting with a crew out in Montana right now that's having some issues, and I've given them some.
Is that the prequel?
Yeah. And they're having some issues with camera and follow focus, and I'm trying to sort them out. So yeah, I mean, frequency coordination is a thing that's part of our future, it's part of our universe, and if you're using gear like this that has the ability to filter out all of that garbage in the first place, then your chance of success is going to be exponentially higher.
And this is something I could have done, but I don't have the time when I'm in prep to start organizing all of this. I mean, the fact that I even got this off the ground with Cujo's help was great, but I don't know about you guys, but I'm slammed in prep time at the beginning of a shoot and trying to manage, you know, five or six departments, RF coordination. My plate's too full to focus on all that.